Hi everyone, welcome to the new subject called Electrical Circuit Analysis 1, prescribed by JNTUH Hyderabad for first year, first semester Electrical and Electronics Engineering students, which is part of R22 regulation. Now let us discuss each unit independently. So coming to the unit 1, so unit 1, the title is Network Elements and Laws. So this is the syllabus prescribed by JNTUH and I have made it into independent points like this. So in this unit, you can see you discuss about active elements, which are mostly sources, independent sources, dependent sources, ideal sources, practical sources, voltage sources, current sources we discuss. And later we discuss about each element which are called as passive element like resistor, inductor, capacitor. We also discuss about the derivation for energy stored in inductor and capacitor. We discuss Kirchhoff's voltage law and Kirchhoff's current law. We also discussed about source transformation, how a voltage source is transformed to a current source and how a current source is being transformed to the voltage source. Later, we discuss about a topic called star to delta transformation, like star converting into delta and the vice versa, like delta connecting conversion into star. Later, based on the Kirchhoff's voltage law, we discuss about mesh analysis, super mesh analysis, node analysis, and super node analysis. So this is the complete syllabus of the unit 1. If you look at unit 1, the first thing which we have to understand, it is a very basic unit to understand the advanced concepts which we will be studying from the second unit. And later we discuss mostly of the DC. We work with DC circuits in this unit 1. And coming to, we solve many circuits from a very simple circuit to a complex circuit. So to get practice and get used to the analysis of various electrical circuits. Now coming to the unit 2, which is called as single phase circuits. So this is the syllabus prescribed by JNTUH again. And I have changed it into points for the simplification. So basically we work with different waveforms such as sinusoidal waveforms and non-sinusoidal waveforms. Sinusoidal waveforms, you might be clear, but non-sinusoidal waveform, we study about square, triangular, rectangular, trapezoidal, pulse, sawtooth, the different waveforms we study. So we study about their RMS value, average value, form factor, peak factor, and other parameters. And these waveforms are represented in the form of phasors. Later, we analyze AC circuits, like because it is a single phase circuits, we analyze series combination, parallel combination, series parallel combination of different AC circuits. So in it, we find out voltages, current responses, active, reactive, and apparent power. We draw the phasor diagram. In the main course, we also study about impedance and admittance parameter also. And the next point is we draw the locus diagram for series RL circuit and series RC circuits and also different parallel combinations. The last topic of the unit is we study about electrical resonance. For series circuit, we study about electrical resonance. And for parallel circuit, also different combinations, we study about parallel resonance, in which we concentrate mostly on, resonant frequency, bandwidth, and Q factor. Now, this unit, if the overall view of the unit is we work with AC supply with different frequencies, different voltages. We try to analyze voltage, current, power, phasor diagram, phase differences, phase angles, rectangular polar, polar to rectangular conversions. We get a lot of knowledge by studying this unit about the practical world actually. Coming to the unit 3, it is all about network theorems. We study about various theorems present in electrical circuits. This is the syllabus which is prescribed by JNTUH. Again, making it fine, we totally get into 8 theorems actually. So these are the 8 theorems which you study in electrical circuits, and these theorems are used in your future, like second year, third year, and final year to analyze various complex situations. So totally of 8 theorems, the statement of the theorem is required and the explanation of the theorem is required, and doing examples and solving problems is majorly concerned in this unit. We don't think about the proof of this theorem. Suppose, let us take the first theorem, superposition theorem. The question can be like this from JNTUH question papers. State and explain superposition theorem and with an example. So we have to state it, you have to explain it, and you have to take an example and then solve it. Or sometimes state superposition and explain it, and find the current passing through some resistance 3 ohms by using superposition theorem. That kind of question can also be asked. And in this unit network 3, we solve both DC networks as well as AC networks. Now we'll go to the unit 4, polyphase circuits. As all of you know, poly means many. So we discuss about three-phase circuits here. This is the syllabus which is given by the JNTUH. And I have made it much better. Here in polyphase circuit, we study about star to delta connections, analysis of balanced circuit, unbalanced circuits of various combinations, and we measure three-phase circuit when they are balanced and also unbalanced actually. And so this unit is very important in the near future because, whenever you study about generation or transmission or, machines, three-phase machines, the basic thing which you study in this unit will be helping you to understand the major concepts. And you learn a lot from this unit, the basic fundamentals, the basic relations, and how it can be done. You study from this unit 4. Now we go to the next unit, unit 5. So unit 5 is into two parts basically. One is coupled circuits and the other one is topology. So coupled circuit is all about magnetism, like electromagnetism from the fundamental laws, or basically from Faraday's laws of electromagnetic induction. It starts. We study about self-EMF, self-induced EMF, mutually induced EMF in such a way. We have self-mutual inductance, self-inductance and mutual inductance. How well the coils are being coupled, called the coefficient of coupling. And also, whether mutual inductance is positive or negative, we study about dot convention being assigned for that positive or negative. We do analysis many coils or electromagnetic circuits with mutual inductance. That is the first part of unit 5. Coming to the second part of unit 5, the graph, the study of the graph is called as topology. We make our electrical circuit as like a graph, and we study basic definition like what is a tree, what is a graph. And from this tree and graph, we are going to take out few matrices like incidence matrix, cut set matrix, and tie set matrix. So circuit matrix is also called as tie set matrix. So from these matrices, what we are going to do is we are going to find out KVL and KCL. And finally, we are going to come back to this circuit. So in unit 5, so you study magnetism as one part and also topology as another part. So this is all about unit 5. And, this is how I have sorted in a better way. And when and where do we use this electrical circuit? So if you want to understand the high level subjects in your second semester, second year, third year, final year, you have to compulsory know the fundamentals. The foundation comes from this electrical circuit analysis. If you want to do some projects, then the subject is really important because it covers majority of the electrical things. If you want to write gate examinations for your, for your central public sector unit jobs, or to get into IITs for your masters or NITs or any other organization with fellowship, then gate is mandatory. Then definitely questions will be asked from this subject. If you know concepts from this subject, you can understand the other subjects, or you can analyze another subjects very easily. So if you want to get placed in the core sector, there would be definitely questions from this area. Even in software, I have encountered many of the students who are telling like the HR or the technical round, we're asking about basics of the electrical things. Even then also you require. So if you want to write any competitive examination, either in private or public or state level or central level, so questions comes from this subject. So either government jobs also you get it. And finally, apart from all these things, if you want to become a true engineer, if you want to understand the subject all over the 4 years, then you should have a good knowledge, or, you should have a thorough practice, and you should have a complete knowledge of this subject. That I can suggest you with that. So that's why electrical circuits one plays a very important role in in studying the subject. With all these things, the textbooks which are referred by JNTUH are being given here. So these are the textbooks. If you go through my videos, you can understand the concepts given in the textbooks actually. So with that, I convey thanks to all of you. Thank you very much for listening the sessions, and I'll be adding a few more videos in this channel. Please watch them. Thank you very much.